Okay, today we're going to do Unit 7, Notes number 7. I'm sorry about the background noise. The copier is going also. Today we're going to do writing from a graph. So whenever we write from a graph, we're still going to look at our regular equation. And then there's a couple of, we're going to have to find 3 of our values for our exponential function, the a, the b, and the d. So let's first go over our characteristics again. So if you guys remember, your a value stretches or compresses the function vertically. So you'll need to know this for your transformations. And we're going to skip down, and then the a value also reflects it across the x-axis. So whenever we're writing our equation from our graph, how we find the a value is we take our y-intercept minus our d value. And we're going to talk about how to find our d value a little bit further down. Next, we have our d value, which is the one on the end. This is what shifts our function up and down. And like I said, the d value is our horizontal asymptote. So a majority of the time, our horizontal asymptote, whenever we're finding it from a graph, will be 0. So normally our a value is just our y-intercept. And then lastly, we have our b value, which is our base. Now our base, in order to find that, we have to find what we call the common ratio between 2 points on our graph. And we're going to talk about that today. So let's go down and get started by writing the equations. So whenever we're looking at our graph, we want to find 2 things. We want to find 2 points. The y-intercept will always be a point. You either want to go left or right. I prefer going right, but sometimes you'll have to go left. This one, the next point would be right here. So my 2 points would be 0, 1, and 1, 2. Now, whenever I'm talking about common ratio, you have to think about what number did I multiply to get to my next y value. So I multiplied by 2. So that means my b value is 2. Next, I need to find my horizontal asymptote. So that's the line that the graph sits on. This one's y equals 0. So our d value is 0. And lastly, my y-intercept. My y-intercept is right here, which is 0, 1. So that means my a value is 1. I take all 3 of my points and I put them into my equation. So I'm going to have y equals 1 times 2 to the x plus my d value, which is 0. Okay, let me know if you guys have any questions. So it's pretty much going to be the same thing each time. So next one, y-intercept. And then our next point, it looks like it's going to be right here. So we're going to have 0, 3, and then 1, 6. You always want to write your points from left to right on the graph in that order, or else you're going to mess up your common ratio. So from 3 to get 6, I'm going to multiply by 2. So that means my v value equals 2. Horizontal asymptote is 0. So our d value is 0. And our y-intercept is 0, 3. So my a value is going to be 3. Take all these 3 numbers and plug them into your equation. So you're going to have y equals your a value, which is 3, times your b value to the x, and then plus your d value, which is 0. Okay, let me know if you guys have any questions on that. Let's move on to the back page. So these 2, I want to kind of go back to the first page. So the first 2, we can see that they're both growth. So if they're growth, your b value is going to be a whole number. While on this page, we see that both of our functions are decaying, so that means our b value is going to be a fraction. So keep that in mind. So this one, our y-intercept is 0, 1. Well, you can't really find a point if you go right, so we're going to have to go left. Now, I've said this multiple times. You're going to have to make sure you list your points from left to right. So I'm going to have negative 1, 3 first, and then I'm going to have 0, 1. Because if you list them in the opposite order, you're going to get the wrong common ratio. So to get from 3 to 1, I divided by 3, which is the same as multiplying by a third. So this means my b value is 1/3. That it matches, because if it's decay, I want my b value to be a fraction. Your d value is your horizontal asymptote. Your horizontal asymptote on this is 0. So my d value equals 0. And then my y-intercept is 0, 1. So that means my a value equals 1. I'm going to take those 3 and plug them in. So I'm going to get y equals 1 times 1/3 to the x plus my d value, which is 0. Okay, let's do the last one. Y-intercept is 0, 2. And then our next point is up here at negative 1, 6. So we're going to have to list negative 1, 6 first. And then we're going to list 0, 2. To get from 6 to 2, I divided by 3 or multiplied by a third. So my B value is 1/3. D value is your horizontal asymptote, which is 0. So my D value is 0. Then my A value is my y-intercept, which is 0, 2. So my A equals 2. Take those three, plug them in. So I'm going to get y equals my A value, which is 2, times my B value, which is 1/3. Raise it to the power of x, and then plus my D value, which is 0. And that is all we are doing. Okay, going down to the next one, it says write the equation of an exponential function with a base of 2 and a y-intercept of 5. So we know our b equals 2. And then our y-intercept, which is our a value, can also be 5. So our equation could be y equals 5 times 2 to the x. Now, b says write the equation of a different exponential function that has the same base. So the only thing that needs to stay the same is the 2 to the x. The 5 needs to change somehow. Doesn't matter what you change it to. I'm going to change it to 3. Then my base needs to stay the same. So it just has to be a little bit different. Okay, now example 4, describe the transformation. So the first thing we want to look at is our a value. Is it negative? No. If it were negative, it'd be a reflection over the x-axis. So then I look, is my a value bigger than 1 or less than 1? If it's bigger than 1, it's a vertical stretch. If it's less than 1, it's a vertical compression. So since it's less than 1, it's going to be a vertical compression by 0.7. Okay, then I look at my D value. It's negative 3. That means it's shifted down by 3. So you can have up to 3 transformations. But if your a value is not negative, you will probably just have 2. Okay. Example 5 says complete the table to show if the given exponential function characteristics are the same or different. So I would identify your a, b, and d from both of these. First one, we know our b is 2 because it's in there. If we put this graph into our calculator and sketch it, our horizontal asymptote is going to be at y equals 1. And our y-intercept is going to be at 0, 2. And the graph goes like this. Okay. So on the graph below, our horizontal asymptote is 0. Our y-intercept is 0, 1. And then we have to find our b value. So we have 0, 1 as one of our points. And then we have 1, 2. So our b value equals 2. Okay, so I found some information. So let's go over. Y-intercepts, are they the same or different? This y-intercept is 0, 1. This one's 0, 2. So they're different. Bases, this one is 2. This one is 2. So they're the same. They are both going up. So they're both gross. So that's the same. Domain will always be the same. And then our range and our horizontal asymptote. Those are the last two. Asymptote's on my next page. So we're going to add it on down here. Okay, our horizontal asymptote. You want to look at the horizontal asymptote and then the range. Horizontal asymptote. This one's y equals 0. This is y equals 1. So they're different. Since their horizontal asymptotes are different, their ranges also have to be different. So keep that in mind. Now, if the horizontal asymptotes are the same and they're both going in the same direction, the ranges will also be the same. Okay, let me know if you guys have any questions over any of that. And you can get started on your homework.